Yeah.
Okay, so today's lesson will be solving linear inequalities, part 2. Last time we went over part 1, and today's lesson is just going to be an extension of the last lesson. So okay, so I want to just make sure to go over some problems. I don't know which ones they were. Let me let me pull up. So this was not part 2. I know you did part 2, solving linear inequalities part 2. This is the first one, and let me see which ones. Let's go over this one. K plus. Sorry, let me. So the problem was K plus 19 is greater than or equal to 38. And I asked you to solve for K and then put it in interval notation. Okay, so what would be the first thing to solve for K that we do?
Subtract 19 on both sides.
Yep. So we get K is greater than or equal to 38 minus 19 is 19. So I think you got that part right. And I always recommend graphing it first because it's easier to see what's happening. You can just get the interval notation from reading off this inequality. It says K is greater than or equal to 19. So it's going to be all numbers, all real numbers greater than 19, including 19. Okay, so from that, I can get, so it's going to start at 19. Sorry, it's going to be square bracket. and it's going to head off into positive infinity. It's all numbers greater than 19.
Yeah.
But if you have problems going from the interval notation to that, what you can do is graph it. So you have 0 here. You don't have to do the 0. It's just something I do. And then you have 19 over here. And then you can either rationalize the idea that you have numbers greater than or equal to 19, or you can just look at the fact that it's this, consider this as an arrow that's pointing in the direction of your graph, or where the graph should be. So this arrow is pointing to the right, and it's a non-strict inequality, so you would do a closed circle, and you would point your arrow on the graph to the right, like that. And then from the graph, you can read off the interval notation. So you start here at 19, and it's going off into positive infinity. So you would do something like that. And there's your, yeah. Okay. And what was the other one? I think the other one was similar. Yeah, this one. So 3 over 14 is less than n over 14. So 3 over 14 is less than n over 14. And what would you do to, what would be your first step to solving for n in this one?
Multiply the entire thing by 14.
Yeah. So when I do that, you're going to multiply that, and you're going to multiply that by 14. You're going to end up with 3 is less than n. And as a graph, again, it's 3. So this, the proper way to write this inequality is with your variable on the left. So it would be 3 greater than, or n is greater than 3. And on the graph, you would have 3, and then just point it in the direction of this arrow. It's pointing to the right. So, and it's an open circle because it's a strict inequality. Or you could realize that the inequality is telling you it's all numbers greater than 3, but not including 3.
Yeah.
And from this graph, you can see that it's an interval notation. It's 3, not including 3, 2, positive infinity. Okay?
Yes.
All right. And as a check, you could always pick a number within this interval. So the interval is saying between 3 and positive infinity, not including 3. You know, you could plug in 3. This interval is saying it doesn't include 3. So what happens if you put 3 in here? You get a false statement. 3 over 14 is not less than 3 over 14. They're equal. So 3 would not work. But if you put in anything like 4, 5, 6, or 7, then you would get a true statement. That's one of the ways you can check whether you have the correct interval.
Yep.
All right. So let's move on to our today's lesson. So we're just extending the same concepts, and then applying them to slightly more complicated looking inequalities. So here we have 31 plus 8x is greater than 5 times the quantity of 3x minus 5. And the first thing I'm going to do is simplify. So 5 times 3x is going to be 15x, and then 5 times 5 is 25. And then on the left, we have 31 plus 8x is greater than. Okay, and then I'm going to isolate by moving the x to the left side. I'm going to subtract 15x from both sides. And then I'm going to move the constant to the right side by subtracting 31 from both sides. And when we do that, we get, so 8x and positive 8x and negative 15x is
7.
yeah,
Negative 7.
negative 7.
Negative 7x.
Greater than, let's see, what's negative 25 and negative 31?
Positive, wait, no, negative 54.
So we have two negatives, so we're adding.
56.
Yeah, so negative 56. We're going to divide both sides by negative 7. And when we do that, we get x is less than or equal to, because the sign flips, we're dividing by a negative. What's 56 divided by 7?
8.
Yeah, positive 8. And it wants this in interval notation, 8. So all numbers less than or equal to 8. So we're going to start with negative infinity, go up to 8, including 8. So as
Yep.
a graph, this would be, you would have 0 here, 8, closed circle, because it's a non-strict inequality. It's going to point all the way to negative infinity. Okay. All right, your turn. So this says 7 times the quantity of x minus 8 minus 8x is greater than negative 8 plus 7x. And let me know when you're done. Are you done?
I'm done now.
Okay. So we can start by simplifying. 7, we get 7x times 56 minus 8x greater than negative 8 plus 7x. So we can simplify the left side. 7x and negative 8x is negative x.
Minus 56.
Yeah. Greater than negative 8 plus 7x. We're going to subtract 7x from both sides. We're going to add 56 to both sides. And when we do that, we get negative 8x greater than, is that 48?
Yeah.
Divide both sides by negative 8. We end up with x is less than
6.
6. Did you get that? X is less than 6?
Yeah.
Okay. On the graph, it's going to be all numbers, open circle, less than 6. As an interval notation, it's going to be negative infinity, to positive 6 parentheses. Do you have any questions on what we're doing?
No.
No? Okay. Your turn. Again, we have negative 9 times the quantity of 1 plus 8x minus 4x greater than or equal to negative 10 times the quantity of 9x plus 9 plus 11. And let me know when you're done.
I'm done.
Okay. So, again, we're going to start by simplifying both sides of the inequality. We get negative 9, negative 72x minus 4x greater than negative 90x, negative 90 plus 11. And what do we get on the left side here?
Negative 9 and negative 76x.
Good. On the right side, what do we get?
Negative 90x and then negative 79.
So I'm going to move this 90 to the left side by adding 90 to both sides. I'm going to move this constant to the right side by adding 9 to both sides. And when we do that, what do we get on the left side?
14x.
Greater than, and then negative 79 and positive 9.
70. Negative 70.
Divide both sides by 14. And does 14 evenly divide into 70?
Yeah.
50
by
plus
5.
20. Yeah. So it's going to be negative 70 divided by 14 is negative 5. Interval notation. X is greater than or equal to negative 5. It's a non-strict inequality, so we're going to do a closed circle and point it all the way to positive infinity. To do interval notation, we're going to read off from the left. So we have negative 5, square brackets, and then positive infinity. Is this what you got?
Yeah.
Okay, good. All right, now we move on to the last topic of today, which is three-part inequalities. Okay, this is just an inequality where I believe we did something similar last lesson, except the middle part wasn't an algebraic expression like this one. But it's a three-part inequality.
I
And
think I did this on the Google Doc.
oh, this exact same problem?
No, but like something like that.
Okay. Okay. So the idea is the same, but as it says here, whatever you do to isolate x, you're going to do it to all three sides. Okay. So in this one, we have -7 is less than or equal to x minus 1 is less than or equal to 9. Okay. It's just saying that this, whatever is in the middle, is between -7 and 9, including -7 and 9. And to isolate x, we're going to add 1 to all three sides. Again,
Yeah.
the other strategy is to break this up into an and statement, but that's, you don't have to do that. It's more work, right? So the other, just to show you, you can break this up into x minus 1 is greater than or equal to -7, and x minus 1 is less than or equal to 9. And then solve it this way, and you should get the same answer. But again, this is more work. And you don't want to do more work, okay? So we're going to add 1 to all three sides. And when we do that, we get -7 and 1 is -6 on the left side. In the middle, we just have x. And on the right, we have 10. 9 plus 1 is 10. And so this is our inequality statement, which can immediately be translated into interval notation as square brackets -6 to 10 brackets, because x is between -6 and 10. So this would be your answer. If you wanted to graph it, you have -6 here, you have 10. It's going to be a closed circle and a closed circle, because they're both non-strict inequalities. Okay?
Yeah.
Okay. If, however, you wanted to go this route, so on the left, you have x minus 1 is greater than -7. That's going to be, you're going to add 1 to both sides. You're going to end up with x is greater than or equal to -6. And you're going to end up with, on the right, x is less than or equal to 10. And then to graph this, you would do this exact same thing. You have -6 here, you have 10 here. X is greater than or equal to 10. That's, you have a closed circle and it's going to point to positive infinity. X is less than or equal to 10, closed circle, and it's going to point to negative infinity. And since it's an and statement, your answer is going to be the intersection of the two, which is that.
Yeah.
Which is the exact same thing as this. Okay?
Uh-huh.
And again, this, however, you have to remember that this only works with less than or equal to or less than. These less than, so if you have a compound inequality, less than or less than equal to means and. Okay?
Uh-huh.
All right. Last problem. Go ahead and solve this and let me know when you're done.
I'm done.
Okay. So what do we do? What's the first thing we do?
Divide -9 on all three sides.
Good. And when we do that, the -9's cancel, and we have x in the middle. Now, here we have -90 divided by 9. Since we're dividing by negatives, we have to remember to flip the equal signs.
Yeah, the signs flip.
Like that, because both sides are being divided by -9. And what's -90 divided by -9?
10.
10. And what is -27 divided by -9?
3.
3. Good. And you want to rewrite this into the proper manner, which is you want the lower number on the left side. So it's going to be x is greater than or equal to 3 and less than 10. And now, as you can see, we have an and compound statement. So it's saying all numbers between 3 and 10, basically. So on the number line, you have 3, 10, closed circles because they're non-strict inequalities. And it's going to be all numbers between 3 and 10, including 3 and 10. And an interval notation is square brackets, 3 and 10. Is this what you got?
Yeah.
Okay, good job. All right. So that's it for today. And I believe you already did the homework, right?
Yeah.
Yeah. So there's no homework for today, but if you want to get ahead and look at, so you're free to do any of these ahead of time, okay?
Yeah.
So we're in section 2 now. We're done with section 1, and we're in section 2, and we're doing linear equations in 2 variables. So we're doing that. We're learning how to do plotting of ordered pairs on the coordinate system. We're graphing linear equations, slope formula, equations of a line. So there's different forms of a line. There's the slope intercept form, the point slope form, and the standard form of a line. There's parallel and perpendicular lines, graphing inequalities, and finally, we're going to be introduced to functions. Okay?
Yeah.
All right, so that's the next section, and that's it for today. Thank you.
Okay, bye.
Bye-bye.